Welcome everyone to another glorious future nostalgia video here with the highest end Sgi O2 400 MHz R12,000 MIPS 64-bit processor back from the year 2000, the highest end entry level workstation you could get. I could make a dedicated video, so coming here I have the Sgi O2 already since the beginning of the pandemic. I auctioned that already 3 years ago, but we just were so busy with our increasingly simply amazing Linux distributions that it took me until today to yesterday and today to finally freaking get T2 running. So the complications of that are multiple. So we live are syncing here. So is the system entirely stable? Demask tail. It works better than I expected. I could give you a rundown over the specs and everything, and yes, I have the matching flat panel display. More to that in a coming video. You probably want to share, like, and subscribe on the main channel. I will most definitely start soon now that our operating system is in AAA condition. Make a dedicated video of all those outstanding machines. But to summarize that, MIPS, of course, Sgi, known graphic high-end workstations, MIPS, that processor architecture, 64-bit, year 2000, otherwise mostly unheard of, and otherwise, of course, SCSI and high-end gear and OpenGL in hardware. But Apple was not first with unified freaking memory. That is one of those systems. Surely there were other differently earlier unified memory systems, but this Sgi O2 is future innovation, nostalgia, unified freaking memory with the framebuffer and OpenGL rasterization engine. Now this particularly model, actually Sgi O2 has previously been supported with Linux and could theoretically previously been run with T2 Linux. The reason this particular Sgi O2 were never stable, and I did not, like, when I got it, I messed with it for a weekend. I spent a weekend debugging the bootloader and so on. The problem with this high-end Sgi O2s are that this MIPS 64 R10K, R12K, R10,000, R12,000 processors, T5 or so, internal spec name, those are one of the first out-of-order speculative executing processors. And it's basically the same processor I have in my Sgi Octane, and there it runs without an issue. The issue is that the O2, unlike the Octane, is not cache coherent. So with a system bus glue logic there in the Mhz and crime and whatnot ASICs, actually the speculative load and stores of this processor invalidate cache lines, so they are not invisible to the rest of the system in this otherwise cache not coherent system. What that means is that while the processors, like if you run code, that code runs correctly. However, the speculative, like similar, hey, Intel and AMD, latest and greatest speculative execution stuff, not too error prone and stuff too much, meets a 20 years earlier Sgi freaking R10,000. So with normal CPU operations, that is not a problem. The problem are DMA transfers. So what happens is, and that is why this particular high-end R10K and R12K never have been stable with Sgi O2, and which is why I didn't, the last 3 years, not spend the most efforts to actually install T2. I sourced it relatively affordable. It was standing here nicely. Not now is the time. It runs better than expected. Of course, I had to hack quite some stuff up. What happens there, the instability that occurs, is that kernel code for drivers is invalidating cache lines while DMA operations are in progress, right? You program the hardware, your SCSI, your adaptive SCSI controller, your O2 specific Sgi specific Ethernet thing here of Ethernet of Mhz or whatever. Anyway, so you program DMA stuff, and this DMA is in progress, and while it's in progress, other code runs, and that other code could speculatively invalidate cache lines and mark cache lines dirty And then, for example, you have a DMA operation that writes data from your Ethernet, from your SCSI controller, and speculatively executed code marks the cache line in the processor as invalid. It needs to be flushed back to system memory, and the DMA operation, the SCSI adapter, the Ethernet, writes to system memory, and then the cache is flushing back invalidated cache lines with the old data. So that is obviously leading to random data corruption and other such stuff. There are various techniques to mitigate this. One is the thing is that doesn't show on the Octane is cache current, so the cache currency protocols take care of that on the hardware level. There are multiple, like 20 years ago it was discussed, maybe even with people from SGI. Of course the SGI, the IRIX kernel also had to deal with that. And that only affects the R10,000 and R12,000 models, right? The entry level R5000, R5K models are not affected because they're not freaking speculatively executing instructions. There are various techniques that were discussed that are to this day not implemented in the Linux kernel. One is either the chipset for the O2 actually has some special mode to select some memory region of the kernel segment in 4, 8, 12, 16, I believe in 4 megabyte increments from 4 to 30 megabyte or so that you would specifically map your precious kernel code in that first kernel segment and have other DMA buffers allocated elsewhere, and the chipset would actually trap writes to above this segment, for example. There was some internal code name of SGI, like something like Candy or something of that sort. I need to look that up. Other things are simply flushing the caches more. So I'm obviously not in an afternoon rewriting the Linux kernel to specifically deal with this just O2 and IP27 whatever impact 2 affecting issue. For the IP27, it was workarounded by simply patching GCC. This patch is in the meantime upstream since over 15 years to have GCC generate code where speculative load and stores could be in effect to flush the caches, and that is actually what I use. So that is used in the Linux kernel for IP27, which does not have this chipset-specific memory protection implementation anyway. And I simply use that. Other people have also tried that, like, for example, Gentoo Linux 10 years ago. But this stuff was never made upstream, right? So I'm obviously certainly the only one who is running the latest Linux kernel, right? 6.6.10 from the other day. And also, so I'm happy to report upstream mainline kernel can work. I mean, obviously I haven't patched, otherwise, I mean, it would instantly crash on boot. Stuff would be like non-working SCSI controller, like without that, without load and store and validation there. On the GCC side, even the SCSI controller would not even work at all. And otherwise, without that, it would crash very quickly with network access and stuff. So that is the only mitigation I'm currently using, the GCC automated load store cache flushing in the kernel. It does not work perfectly though, although it works surprisingly good, right? I'm currently R-syncing. Basically, I wanted to quickly report that. I could make a technically demonstration. Probably it's not the most worthwhile to make a technical demonstration. Probably those who are in computer science understand what I'm talking about. If all those words are new to you, certainly that is a chance to Google cache currency or other currency protocols, caches, what are caches and stuff, computer architecture and similar such stuff. Also, so how much in the meantime, even on this tiny little side project of like keeping museum stuff alive, I spent easily a week over 3 years. When I got it, I spent a whole weekend debugging the ArcLoad bootloader, which of course did not just work in specific stuff. That bootloader code is in T2. However, for some strange reason, like for 3 years already, T2 is the only Linux distribution who can load 64-bit kernels on 32-bit arc load over network, or specifically the init actually. So you get the stuff, you know it's quirky, the first weekend just spent on bootloader. Just yesterday, like basically it was standing there, then for most of the time I only test booted IRIX and stuff, like checking 100% input, control your ISO 9000, whatever, certification, checking every random stuff you get from eBay actually freaking works. It was collecting dust here and thought like, 2024, maybe it's a good time to start to use some good old vintage retro stuff. And I spent another day also on the bootloader again, surprise. Somehow I had it network loaded. I could not, for the whatever name of God, get it to get the ArcLoad bootloader network booted. I'm pretty sure I have actually an Instagram like 2024, 2020, 2021. Of course you have an Instagram photo of your network loaded ArcLoad. I think it just worked actually 3 years ago, except it couldn't load an init, but I debugged it. So in the name of God, I have no idea why it does not work now. I debugged this also for hours like that. Anyway, I booted the kernel. I now directly booted the kernel over the network, which is not ideal because I would want an init ID and I need this working anyway. So the story is not over, right? So otherwise, SCSI works so far so good with XFS. Ethernet works mostly fine except timeouts, but hey, it's like RX underflow stuff. It's like, yeah, I mean, we have here gigabit Ethernet or 2.5 gigabit Ethernet and stuff with a 100 Mbit vintage Ethernet thing. Is like, yeah, go figure. Otherwise, NFS root booted, R-syncing this to the SCSI drive, and even to my surprise, the ALSA driver, it's like, take that, pulls audio, ALSA drive works. I was just listening a couple of times to some good WAV files that sounded better than Revox reel-to-reel. Currently, I'm still syncing this to the external SCSI drive for a little bit improved performance, hopefully. There is still plenty of stuff to do, right? Can we ship this like this? No, unless our name is Oracle. We would not ship this yet. Also, the framebuffer works. Xorg, I only tried Xorg earlier today over NFS root, so that went up in flames. With probably this speculative cache line stuff. I believe because I got there some Mhz or whatever errors that were. 15 years ago, Xorg was set to work. We will see. So there's still plenty of stuff to do. The NetBSD people of also, ideally we would want hardware isolation, right? The NetBSD people of all good fans and friends actually have for like 10 years, it was on Slashdot, a little bit over 10 years, maybe 15 years in the meantime, probably since 15 years, the NetBSD people have a hardware isolated Xorg driver that they didn't upstream and only have a NetBSD and has NetBSD specific stuff in there. That does hardware isolated XAA isolation for Xrender and transparent stuff like splitting text and transparent icons. Amazing stuff. So yeah, theoretically we could port this to T2. First we would need to get our Xorg server booting at all. So then porting the NetBSD initially coded driver there, xf86-video-crime, I believe, because crime is a ASIC, whatever rendering, something chipset rendering and whatever, fancy name. First would be to get this to work at all. Theoretically, we could write an OpenGL driver. The chipset looking at this NetBSD sources, this is a very simple edge walking hardware, like the S3 Verge and 3DFX Voodoo. Previous video, we did drivers on that. Theoretically, that should be possible. The question is, that is the thing, I mean, of course it is kind of sort of pointless today. You could just run IRIX or some modern stuff. But if we really wanted shell like subscribe, should we really do that? Nobody outside SGI has ever done that. That would be interesting to see this 3DFX-like, Voodoo-like edge walking stuff, split textures faster than hopefully S3 Verge. That is all the stuff, right? It makes me a little bit nostalgically sad of it could have been 15 years ago. I mean, of course, there were not specification and stuff had to be reverse engineered. But, I mean, yeah, obviously 15 years ago it was already pointless to write more drivers than NetBSD has done. The more people shall subscribe, the more we can put time into that. That's basically the quick summary. I probably should make a quick summary 20 minutes later. This stuff kind of, I mean, on one side it makes me fat. In general, it makes me happy to have this outstanding things. Maybe I should either consult with a technical museum here in Berlin if they want to make an Hexacode corner where I could store some of my collection of collecting less dust, or open a museum myself. Otherwise, it makes me really happy when it finally works, like sitting here with my vintage Sony professional dynamic stereo studio kind headphones, MDR 7506, not a bit advertisement free studio, like sitting here and enjoying the highest end affordable $17,000 of year 2000 high-end fame. Like if you basically this is the equivalent of a spec'd out Apple Studio thing, if you would want to call it, or even freaking Threadripper, if that would make sense, is of course otherwise absolutely outstanding, right? And I don't understand the hate of other people on forums like Foronics of delete, obsolete and stuff. Like, hey, it still looks amazing, it's still precious, like other people drive a vintage car like your VW Beetle or Porsche stuff on a Sunday and stuff. I don't understand the hate on some news sites of deleting old vintage stuff when that is what people can have fun with on a weekend. I will continue to make this stuff work better. All right, last but not least, so yeah, share, like, subscribe if you want to see me spending more time potentially live here on this channel. Wait, why do I rsync this again? This is not ideal. Did I not? I didn't delete it. Let's, I don't need this twice. Where did I? Probably here, rsync. Do we even see that? No, we don't see that. Alright, because, okay, you know what, do we have Tmux here on? Obviously we have Tmux on the Sgi O2, or? Ah, local, okay, fine. Whatever, rsync, I only want here rsync that with exclude T2 source, because I rsync this already to the top level. Last but not least, unfortunately supporting this kind of machines is an absolute nightmare. Theoretically it would be easy, like, hey, this hardware, it is that is relatively simple, like RISC and S3 Verge, 3DFX Voodoo, edge walking, texturizing hardware stuff. However, neither SGI nor the Linux kernel or other Unix kernels make it particularly easy. The problem is that all those machines, and that is really a major design flaw from SGI, need a dedicated Unix kernel. Even IRIX had dedicated kernels for IP 20, 22, 27, 30, 32, 35, and 37 and whatnot. All those IP are their internal SGI IRIX model numbers. IP30 is Octane, IP32 is O2, IP27 I believe is Indigo 2 or something. Anyway, something of that sort, right? So they have this IP numbering scheme, and the problem is they have all different load addresses, they have all different, at times interrupt or other bus, they have all different bus things. The O2 has more standard PCI with either, the Octane has this Expo crossbar interconnect and stuff. And then also the Linux kernel is not implemented for that. The Linux kernel or other Unix kernels, NetBSD, OpenBSD and stuff, they have all this hard-coded, like if def, IP, whatever, so you can't build. The problem is you can't build. I mean, technically you could to some sort, but no Unix or clone BSD Linux kernel has implemented generic, similar to ARM, like the 32-bit ARM historic legacy problem with Linux. There is no multi-arch support kernel thing, and even if you could, at least some, let's say we could somehow multi-arch Origin 200, Octane and O2, this still would not just work because of the different processes and the visibility of RISC, MIPS, implementation details. For example, even in the O2, we basically would need two kernels. We would basically need O2, I mean, yeah, we would need to at least build the kernel multiple times. Once for non-speculative classic MIPS code R5000, and then at least a second variant for R10K and up with that specific workarounds. The thing is, you could not even share the workarounds, at least not if we use a crime chiplet lever. I think, what did I say? Candy of something of that sort, whatever the internal code name was for this ASIC memory address mapping thing. Because as far as I've seen from some document I saw from SGI, that was not implemented in earlier versions of the crime ASIC, right? Because obviously SGI designed it in 1996 or whenever they started, or 1994 or 5, whenever they started with the O2 project. They designed the ASIC with the R5000 MIPS CPU in mind. So obviously they didn't have to design and implement any speculative load and store workarounds. So the earlier versions of that don't have that. I mean, okay, you could theoretically program that dynamically, but what I wanted to say is you could not even just use this workaround, because only later revisions of this ASIC do implement that, right? Sure, okay, you could like, if you would want to do that, you could of course dynamically do this programming only for R10K, but you would still we would still need to implement the Linux kernel. But if we don't implement that and we use this cache barrier workaround that so far, surprisingly, like everyone always said on the net, like O2 R10K is unstable, don't use it, no production, it's unstable. It's like, yeah, it's, I mean, sure, I mean, other people have been there, other people have done that. Uptime 1 hour, 50 minutes. So far, not so bad, right? But I mean, obviously it was not important 15 years ago, it is less important today. And given the nature of what I just outlined, you cannot just have one ISO and support, no, you cannot, illustration purposes only, you cannot have one ISO and support them all. I mean, okay, you could have one ISO, but you would need 7 kernels, right? You would need Octane, you would need O2 or 5K or O2 or 10K, IP or Origin 200, IP28 or so. Anyway, so let's, so yeah, as you see, this looks surprisingly good, except so this underflow is probably normal, I guess. I mean, I'm like 2.5 gigabit connected here, so I guess that's normal. Maybe I patched that out, and I need to look at the code, because I get, like, when I've listened to precious high resolution audio stuff, I got dropouts, other underflows. Maybe this is busy waiting or so until like 2024, and you need to optimize the Ethernet driver for sustained gigabit switch load. So we can do some things better. So the usual thing, like fully supporting that, will need some work. Somehow the bootloader does currently not load for me over network. That needs to be debugged. What's up there with arc load? Currently xorg doesn't start, right? This crashes relatively badly. I need to see if that also works over SCSI. Maybe that is some NFS root thing. We will see. So even with this workaround is obviously incomplete. I mean, I'm extremely surprised how well this works. I also wanted to build something. I built Lua previously, of course, the performance, although this is the highest end unified memory, half a gig. I mean, this is obviously nearly 20, like around $20,000 US, right? I don't know, I've not priced in the memory. I don't offhand here know what the precise memory price. I mean, obviously 512 megs of memory, the year 2000 already cost quite a bit. So did I actually, all right, we wanted, I think this is here. So yeah, $20,000 US plus inflation. It's of course not outstanding today. Where are we even? I'm in tier, so. This I touched just for some check. Let's change route probably in here. That's our new change route. Maybe mount a new temp fs. And all right, this was, we can, I believe, delete that because I have that here. Yeah, I pre-synced that already for some load test before I sync everything. Because mind you, people wrote on the internet it's unstable, don't touch it. Like, yeah, it's unstable, don't touch it. Works mostly so far. Anyway, yeah, obviously before we ship it in production, it probably should survive most of a normal boot from ISO, install and xorg procedure, which currently it neither boots nor boots with bootloader. It currently only directly loaded the firmware as the kernel. Without either, so theoretically there's some stuff to do. And then of course xorg whatever is wrong there. I will also probably patch this away, because in my opinion it is pointless to log. Like for what? I mean, I would say it's a normal condition of sustained network load, so it's pointless to log this and busy with. So that so yeah, no crash yet. Knock on plywood. So T2, I wanted actually to build FBset, which I had to restore also in our mirrors. So also right, you wanted to let's generate the UTF-8. Right, I didn't bind mount dev prop with this that. It is of course a testament how much slower compiler became and how much other bitrate we have. That, I mean, yes, it's 20 years, but somehow it is still, I mean, that is relatively snappy, but you will see, I mean, even this UTF-8 generation thing here will run probably half a minute. Also can set the system-wide time zone just because. Did I even? I didn't actually mount the boot partition yet, I guess. System-wide locale, so that probably will take some seconds to stream, edit, generate, and probably half a minute to... probably, this kind of thing is always a reality check, how much stuff we can still optimize. I would say this should be faster. Somehow this should not be such an expensive optimization. But even this locale generation stuff probably runs half a minute. So I've also the first time I've done that on this Sgi O2. So it could always crash, deadlock, and go up in flames. This is, by the way, serial console here. Oh, it was surprisingly snappy. So did this. Set this. Good, so T2, all right, we wanted Tmux white for you to better see that. And then speaking of which, so yeah, I wanted to build FBset for framebuffer testing purposes. That also disappeared upstream because obviously, all right, so there are so many things. So this was just a summary of hanging out together, like celebrating this achievement. Unlocked. This estimated times are off. They are currently, like the Lua time was off by 2 or 3 because the first thing I built was NeoFetch. This is a T2 source distribution thing. The first package I built was NeoFetch. That is because it doesn't build something not the best reference package, but it is what it is. So it might actually build 2 or 3 minutes, which is of course crazy. Probably 20 years ago when this was high and new, of course compiler were slower, compiler were faster, generating not as good code, but they were generating not as good code faster. My general estimation is like GCC became nearly 10% slower every major release, so it's probably more than twice, if not 3 times as slow easily, at least. Plus, of course, all the code became larger, right? All the C headers, glibc, Linux kernel features, futexes, libio uring, and all the other good stuff, plus macros, feature macros, double, triple the features, right? So GCC 2-3 times as slow, headers and libraries 2 or 3 times as large. So yeah, did I build this verbose? Build it verbose, it should soon be verbose. So the other thing is, the first thing, celebrating it together, just enjoying this vintage and retro stuff. I hope you have as much fun with this future nostalgia than I have, because also until 3 years ago, I've never touched an Sgi O2, right? I've seen it maybe on a Chaos Computer Congress thing 20 years ago. So, but this is kind of stuff like normal people never had that, right? Which coming full circle back to rather being disappointed that stuff gets deleted, and so on, and people don't appreciate that, right? So I accept all the bugs and glitches and stuff, but hey, it's computer science, right? Stuff is buggy and glitchy and stuff that's challenge accepted. Let's go and fix it. It's like, hey, FP said didn't even build that long. Let's take a look at the comments. Welcome, friends and family. Hope you enjoy this. People agree, having fun. So yeah, actually this time was surprisingly close. FP said wanted to, yeah, so this is actually accurate. Interesting. So that this is 80800. Oh, it's probably it, but yeah, I wanted to check that. I wanted actually to see. And so if you're wondering why do we have these packages, I had to restore it on our mirror. Somehow it wasn't on the mirror anymore because we it wasn't on the mirror anymore because we transitioned from all sets and compressed original. So I mean, yeah, it's like random projects. This is really silly that every day I come over stuff not being maintained anymore. Like similar to SGI and Sun stuff lost to history. Even written by Gerd Uta Hofen, so and Roman Zippel. But it's like, yeah, why is this standard stuff like? Where is it now? I don't know. Probably people would say nobody uses it anymore. Here is actually, this is just some in page. Anyway, it's still on our mirror. I have whatever the latest version. I'm not even sure if maybe I should FP set Gen 2 ebuild. So do they have that still? They have FP set. Where do they download it from? Or keyword for RISC-V? Nah. Where is tree and oh darn, where even was that app sys or whatever? This apps. Let's see where they get this from. 2.1, so 2.1 is probably what we had, right? So they, here is some that looks slightly different from what I had. Question is, does this still exist? Oops, also doesn't exist anymore. Never mind. Anyway, I had to restore it on our mirror. It is what it is. I don't have a problem to being one of the last two hosts in our mirror. That it is what it is. One thing, so at least we make small things better, right? One thing is of course testing, having fun, seeing what actually works. How bad is the state? And it's like it's not as bad as it looks. We could fix file diff. So other people never published what they did and done. Unfortunately, I did not fix file diff that here, but you know we could. Oh no, it's in system tree. We could basically archive that if we wanted to. So this is NFS row. Don't need that anymore. So next, theoretically, I could make a, I could, do I have the P3 stuff here? P3, so if we wanted to include that here as Sgi O2 to do, that would be arcload to load, xorg to not crash, or otherwise. The rest is surprisingly, I mean, for all the haters always like unstable, don't touch unstable, it's like, well, it's still there. Maybe, you know what, performance, I did not, I built Lua, let's build either, you know what, let's build Bash, because why not? I changed the optimization slightly, so I disabled LTO, that improved the performance potentially. Disabling LTO halved the build time from 12 to 6 minutes for Lua. But let's do that again, because I'm not sure how much was actually fetching all the stuff over NFS and having it cached. So let's probably redo that and see if local SCSI improves performance. So theoretically, so yeah, port XF86 video crime, I believe, was the NetBSD name for this ASIC thing. What else? I mean, I guess it only, I mean, theoretically, this is, was it Ethernet? Yeah, MEth overflow audio dropouts, but that would be like, if we wanted to ship that in production like SGI did, it's probably, yeah, it's like, yeah. Very theoretically, proof of concept hardware 3D should not be that hard theoretically. I mean, should not be that hard, except infrastructure for allocating, dynamically allocating texture memory and unified memory. But like proof of concept, like not shipping a Mhz driver like this year, but at least a weekend fun of getting the crime rendering Edgewalker engine to actually shade fog and maybe texturize some triangles. What we could already do, so yeah, I also improved once. I mean, of course I found some bugs, right? So I probably did already put something on the to-do, which is probably here, yeah. So our MIPS init.rd apparently has some duplicate lib files which should not be there. So much to testing, and more testing, and the more I look, the more small details I find. I also slightly polished the init.rd output. It's like, yeah, let's see how close we are on 4 minutes 40. The last time with LTO it took 6 minutes something, 6 minutes 40. So let's see. We could also tail that here on the serial console for, alright, this is another, so we are now in MNT or so. That should be here, right? So that's only so slow because it's serial console, 9600 baud, obviously, tail F, var, log, lua out, so like, yeah, let's see. It's going strong. The force is strong with this little one. We could already document, so what I've done here, let's do that professionally, like Linux kernel programmers should, in my opinion, have done that 15 years ago. But the thing is, of course, they don't care anymore, right? Linux is not a fun little hobby project where everyone is contributing their weekend fun on vintage devices. It's brutal 200 million Linux Foundation business, so they don't care about our vintage fun anymore. So let's correct that and document what I've done yesterday and today to get this kernel surprisingly well working, which was surprisingly little. And I'm not saying I invented that, I'm only saying I've done that. Let's delete that again because our SVN up stuff has just done it. And also let's do one other thing first, which is I slightly tweaked our init.rd. That's the thing, right? I also reverted, like inspired from other news sites that called for flicker-free, no mode set boot procedure. I've actually hidden the T2 boot messages by default too, and I absolutely hated it. And that is the thing, right? Some news sites, no mode set, quiet boot and stuff like, no, I'm a professional and I like my machines Unixy professional. So in the latest release of our increasingly amazing and just working on Sgi O2 even Linux distribution, I re-enabled at least slightly verbose boot messages. The benefit is if something goes wrong, if something times out, even on x86, right? I had some Intel MacBooks that didn't boot anymore and stuff for the only constant is change and regressions. And that is why, in my opinion, and of course it sounds, marketing-wise, it sounds good, right? If news sites drumroll, bing, drumroll, we need quiet, no mode set boots, like no, we don't. we are professionals. That is, it's absolutely a silly macOSism not to see shit, right? And even macOS you can boot verbose. And so I restarted similar to here, right? I rather have some status output, like on some MacBook, like HPAD timer not found, like TS timestamp counter, TSC unstable and stuff, and other shit timeout, right? Do we want a garbage operating system? Hashtag peak bugs like macOS or Windows? No, we don't. So don't pretend to be this kind of, and macOS is the same, right? Just ask Louis Rossmann. Hey, sir, my MacBook does not boot anymore. Can you help me? It's like, did you try verbose boot already? It's like, yeah, slightly verbose, like at least minimal. We're not shy. We don't need to hide this. Tech is amazing, similar to transparent stuff, transparent log stuff. Similar to that, seeing this boot messages here. So that is one change, and the other is today I also polished like this kind of details that most people don't even look right. So today I thought, like, with this initially failing SCSI stuff that I had to load, store, barrier, workaround more, I saw our init.rd output a little bit more, and like, why does our stuff look so increasingly amazing? Because each time I see something, even on vintage and retro machines, then I polish it slightly more. So I polished this init.rd slightly more. It's just the tiniest change, but it looks so much better. Actually, theoretically, yeah, I guess now we leave this at least now. Just some status dots, right? Because I thought the O2 froze when it only waited for the rootfs file system, right? So this is this kind of stuff, like, we're here professionals, right? It irritated us on our precious Sgi O2. It might irritate you or others. So let's mk init.rd, init.rd init. That should be that one. If not, we have version control. And just as promised, now we can do the nice things, right? We updated most of KDE, we updated most of GNOME, we got thousands of things working and stuff, and Rust and Cargo and Firefox and LibreOffice and stuff. Like, hey, now we can turn back to the future, Sgi O2 and other fun stuff. PS3, right? All the fans out there. So, okay, so that is partially old stuff, so we need to revert that. That is also new. And then we have here just the tiniest, so because it was previously printing, it's super small stuff, right? But this is the kind of perfection that then, because then we print out, like, waiting for root, and we print out here the dot without, I removed those, and then I fill, I fill those waiting dots. It's an absolutely tiny cosmetical thing, but it looks so much more amazing. So yeah, further improve init.rd waiting for root status dots. And then the other thing, so to already do, we also finished. Okay, it's so cached NFS root is not that much slower. So it was 6 something. Maybe we have this still in the package metadata var adm packages lua. Yeah, just at, so I mean 20 seconds or 20 seconds, right? So, but this here was, so this was completely cold, first boot ever, NFS root to my Ryzen over 2.5 gig switch, but negotiated to 100 Mbit. So yeah, cold caches, NFS root stuff cached, like probably hundreds of megabytes of shared libraries of GCC and stuff. So yeah, this is local SCSI, like everything probably hot because freshly arsync, so it should be pretty hot caches. And so like oh wait, I know I tell, do I tell bullshit? I know, wait, I tell bullshit. Sorry, this is not NFS root, sorry, this was both NFS roots, I'm sorry. This was LTO, so this was LTO, this was without LTO, and this is, so this is without NFS root, so much to very good. Get confusing by my own stuff here. So anyway, let's try to build Bash just for the performance data of it. That probably builds a while. would not be surprised if that builds. What is the estimate? Easily 20 minutes? Or actually, you know what? Let's bet. First of all, we need emerge to download it, and right, we need to force it because we have the version installed. 24 minutes. Yeah. It is slower than a dual processor, dual 250 MHz Sgi Octane. No surprise. There. So the kernel stuff. Let's do that again. I should have done that the first time, but somehow I didn't expect it to work that well at all today. So let's rebuild. Also best with both. Let's rebuild the news kernel, not for production, but for patching this stuff. So Linux, that's the latest here. And again, if you're into this stuff, your share, like, subscribe, Patreon, GitHub sponsorship, YouTube membership, or super things and chat and stuff is what keeps all this vintage and retro work alive, because otherwise I could totally not do this anymore. So don't forget to do that. What we need to do, so we can't even select our 10,000 because it is marked broken. So fix file architecture MIPS K config. So somewhere here is R10K. Wherever that is, maybe how many? Somewhere there is marked broken. R10. Here, IP32. So let's remove that. So you would, to enable that, you would need to enable it, but then, like, yeah, it's totally broken. So, but let's fix that a little bit more. So this would build, but it would crash and burn quickly. I mean, you probably would get a little bit boot out of it, but it would crash quickly, like really quickly. I mean, SCSI wouldn't work, and like if you do a little bit, it would crash. So bad it is, yes. But to do that, we have here, I added here Arch. So the cheapest low-hanging fruit workaround for this weekend is, right, I patched this into IP32, where would it be? I believe it was platform, somewhere here here. It is in SGI IP32, of course. Or is it? Apparently not. Thought it was there. Maybe here? Here it is. So this is all it's needed to stabilize it as much as not instantly go up in flames. And that works surprisingly well. I mean, I'm surprised nobody else sends this upstream. I mean, maybe we should. And so this workaround is also present for IP27 Origin 2? Origin. No, did I say Origin? I meant Impact 2. What is Impact 2? I believe it's Impact 2. I thought so, at least. Whatever, you get the idea. I mean, we could grab that. Or was it Plus Store? IP28. What is IP28? Probably Indigo. Did I say Indigo too? No, I said something else, right? Nah, numbers. Impact? Did I say Impact? Indigo 2. Anyway, there you have it. Indigo. So yeah, they have there, however, cache barrier stores that may or may not be enough there for some reason, but that was not enough, right? With R10K cache barrier store, it was better, like the resulting kernel was a little better, like maybe Ethernet worked, and it didn't instantly die, but SCSI didn't work, right? With just cache barrier store, SCSI would reproducible error out instantly, accessing the adaptive PCI device. So yeah, and then I tried like, yeah, let's see load stores, like, hey, SCSI works. So far, so good. Okay, configure also works. So let's add that there conditionally. So that would be probably we could. So previously I hard coded that in there, but like that we can't send it upstream. I was like 2024 sending O2 R10K. Hey, with this quirk it mostly works. We can unbreak it mostly for your museum exhibition. So. So that is Sgi IP32 platform, I hope. So yeah, that has... So that evaluates to J, I believe, right? So what I will do, so previously I had that hard-coded in there, but let's see, that should work. As far as I remember, let's wire that to the R10K configuration, right? So that would be R10 CPU R10K. So I believe that should, I believe this has a config prefix. Yeah, of course, this has a config prefix. So config that. I believe that should probably work. At least it documents what we've done, even if that does not work. I mean, pro tip, test all the shit. I will not test this now because of other things to do. But what's not tested is broken, so this has a chance of 50-50 chance of being broken with a typo with set not evaluating to yes or whatever, random shit, or evaluating to yes or 1 or whatever. But it is good enough for me to document that. And so let's document this to hotfix MIPS 64 Sgi IP32 R10K patch. And I mean, maybe while, I mean, this will build some more minutes. I mean, theoretically, if we, how long does it build? Probably should take another quick look at the comments and welcome everyone who joined in the meantime. Matthias, hi, any chance to make T2 run on Amiga? Yes, I believe that was tested. We support Motorola 68K, and I believe a viewer has tested this on an Amiga. At least I got a patch 3 years ago, and I believe he successfully tested it. Was it on Amiga 1200? Anyway, of course it works. I mean, your mileage, a little bit YOLOing, hot fixes and quirking required, but of course we support Motorola 68K. Probably a little bit late, probably answering 10 minutes later here. Question there, what's my take for Ubuntu Fedora to abandoning old CPU architectures? I find it extremely lame. And not only do we currently have fun with 486s and other stuff, but we benchmarked that here, even Phoronix benchmarked it. Phoronix found for most benchmarks it had a neglectable impact on performance. Just what I always tell here, find here, it's called praise here, reiterate here. For general purpose logic command flow in stuff like shells, even GCC and stuff, if you don't have single instruction, multiple data, multimedia, streaming, memory, access, the performance impact is for the most part neglectable. You sometimes gain stuff for bit operations, for other new stuff, of course usually not as AMD, or unless there is some massive movement of data that can be auto-vectorized. So yeah, usually it is 10% or whatever. For 10% I would not, I find it lame. The whole IT, basically recurring theme, the whole IT corporate IT and infrastructure is lame. Lame and bugs and excuses. Lame excuse award. We will, of course, for me it's fine. The more people will use T2 Linux, because who else will still support that? I will support that until I retire, and maybe even then some. And if you're lucky, shell accept grab enough, maybe my son will take over. Or you, maintenance and patches, welcome. But then also, yeah, otherwise, in an ideal world, you can, of course, hardware cap build stuff twice. I mean, if I would be a corporate entity like IBM's Red Hat or Oracle's Broken Linux, I would build this stuff twice, base stuff, x86-64 version 1 or version 0, whatever you want to call it, and then build SIMD heavy stuff twice, and basically support all architectures and new ones, and have the cake and eat it too and call it a day. But we are obviously more perfectionists than that product planners, designers stuff. People happy that their favorite open source dev are online. Happy to hear that. Have a point. This big business decision. Nice font. Why this particular choice? Because the font is named Comic Code, and otherwise to keep my spirits high, the mood and spirits high with the constant flow of hashtag peakbugs and regressions we are here. But also, initially it was a joke, but then I actually like the font of being helping me stare at code and guru meditate for days and nights. So the initial joke became actually a real favorite of having that nicely readable all day long. Explain stuff in detail. Dedicated questions, please ask. So yeah, that stuff is still configuring surprisingly well. Also, we need, so this shell has no, that is, let's kill that away. Actually, there's no other tile, because this doesn't have, shit. Darn. Yeah, some stuff actually wanted to do tail. Anyway, this stuff is going strong, so yeah, that has a chance to work. Let's actually take a look into Linux fix file driver sound MIPS Sgi O2 audio. Yeah, I know. No, I meant that, of course. Oops. Driver with Ethernet. Is it called Sgi? Sgi. Let's see, what do they do there? And that's finished. Actually wanted tail, but no, we've done that already. What do they log there? Debug, MFE debug if otherwise. Loading, MAC address. There are multiple physicals, interesting. Cool. Port to start queue? Did this really? I mean, we could basically move that into some greater there. What was it even? Timeout, right? Underflow. In case there was underflow, and RxDA was disabled. More underflow. So what do they do here? They do print K, spin log, IRQ save in status, underflow, more underflow interrupts will be delivered, effectively throwing us into an infinite loop. So stop processing in this case. I mean, it appears to work. So this other was not this dprintk. This was only if debugging is greater than 1. That was overflow, right? Underflow. Is it underflow? Should this not be overflow if receive overflows, right? I mean, underflow. No, anyway. Let's just make this a dprintk, what they use internally. It makes no sense. I mean, this is recovering, so it's in my opinion, more of... I mean, I probably should just send this upstream. The problem is it's cluttering a lot, right? I mean, it's like, yeah, and it's like, it's underflow. Oh, wait a second, error status. Probably want to, good that we took a second look there. That is building now. That was status. Ah, there it was. Okay, I think, in my opinion, this should also simply be, this should be similar. If you want to debug this, then you want to see the bit pattern, otherwise YOLO, who cares? dprintk. What do they have? So they have current debug there. We mix this a little bit, but I will just manually delete that off. Do we call this hotfix denoise? Sgi. Silent. Quiet. What did I call this? Sgi, right? Oops. No, not sci5. So yeah, only this. This is just from our previous patching. Default production. Probably right. Does that make sense? In my humble opinion, a constant high load flow of Ethernet error status underflow is too noisy, is bit too noisy as default. Anyway, that is how we probably soon reach 100 patches for our Linux kernel. One last thing, I could try again to start X, but I don't want to disturb the bash build here. This bash build. Actually, we could try one other thing while we wait for that. Actually, maybe we probably, you know what? I need to become a smarter businessman here, doing this vintage and retro stuff, and make this a dedicated video. Maybe even later today. We have, of course, more stuff to do. So from maximizing views and your selection of coming back here to the archive, of which you can have probably over 800, if not 1,000 videos in the back catalog for you to access on weekends, rainy days, and otherwise you commute. To watch later. It's probably smartest to end here and do the other stuff in a coming video. As usual, I hope you enjoyed this and learned a ton. Don't forget to share, like, subscribe, maybe Patreon, Super Sync, GitHub sponsor, or just share, like, and subscribe. I hope to see you soon for the next fun stuff, and happy hacking for similar stuff at home.